Hello everyone, today our discussion will be on Bluetooth. Let us see the agenda. First we'll be discussing about the Bluetooth introduction, then its applications, Bluetooth architecture, Bluetooth layers and Bluetooth modes. Let us see the introduction. Bluetooth is a wireless LAN technology designed to connect devices of different functions such as telephones, notebooks, computers, cameras, printers, coffee makers and so on. A Bluetooth LAN is an ad hoc network, which means that the network is formed spontaneously. Ad hoc means we can have a temporary network. Bluetooth technology is the implementation of a protocol defined by the IEEE 802.15 standard. The standard defines a wireless personal area network (PAN) operable in an area the size of a room or a hall. A Bluetooth device has a built-in short-range radio transmitter. The current data rate is 1 Mbps with a 2.4 gigabits bandwidth. What are the applications of Bluetooth? It is used in the day-to-day life. For example, you may use a wireless mouse or it may be a wireless keyboard. It uses the concepts of Bluetooth. And it is possible to have some monitoring devices that can communicate with sensor devices in a small healthcare center. Home security devices can use this technology to connect different sensors to the main security controller. Conference attendees can synchronize their laptop computers at a conference. Now we shall see the Bluetooth architecture. Bluetooth defines two types of networks. One is a piconet and the next one is a scatternet. First we will see about piconet. It is a small Bluetooth network, or we can say it is a small network. It can have up to 8 stations, one of which is called the master. The rest are called slaves. Sometimes the masters can be called as a primary station and the slaves can be called as a secondary station. The slaves synchronize the clocks and hopping sequence with the master. An additional 8 slaves can stay in parked state, which means that they can be synchronized with the master but cannot take part in communication until it is moved from the parked state. So this is a pictorial representation of piconet where we have the primary and the secondary devices. Next one is scatternet. Piconets can be combined to form what is called a scatternet. That means more than one piconet can become a scatternet. A slave station in one piconet can become the master in another piconet. Bluetooth devices has a built-in short-range radio transmitter. So here this is if you consider this one, this is a piconet. Okay, so this is a primary station in the piconet and these are the secondary station. So one secondary station in the piconet can become the primary station of another one piconet, to which the secondary stations can get connected. So now this becomes a scatternet. Now we will see the Bluetooth layers. So the Bluetooth layers are different from the traditional internet layers. Here we have the radio layer, baseband layer, L2 cap layer, and then we will have the application layer. So first we will see about the radio layer, then the baseband layer and so on. Radio layer, they are roughly equivalent to physical layer of the internet model. Physical links can be synchronous or asynchronous. It uses frequency hopping spread spectrum, changes its modulation frequency 1600 times per second. It uses frequency shift keying with Gaussian bandwidth filtering to transform bits to a signal. The second layer is the baseband layer, which is equivalent to MAC sublayer in LANs. Access is using time division, that is time slots are used. The length of time slot is equal to del time, which is equal to 625 microseconds. So each time slot will be 625 microseconds. So during one frequency, a sender sends a frame to a slave or a slave sends a frame to the master. Time division duplexing, TDMA, is a kind of half duplex communication in which the slave and receiver send the received data but not at the same time. However, the communication for each direction uses different hops like what is used in walkie-talkies. So half duplex means when the sender is sending, that means when the master is sending the data, the slave has to wait. When the slave is sending the data, master has to wait. That's said to be the half duplex communication. Single secondary communication. Okay, so here you will be having only one primary station, this is the master, and only one secondary station is considered. So that is called as single secondary communication. It is also called as single slave communication. In this scenario, the master uses even numbered slots and slave uses odd numbered slots. So this is the master, right? Here it uses the even number slots. This is 0 slot, this is 2, and then 4, 6, 8. Likewise, master will be using the slots and the slaves will be using the odd numbers, that is 1, 3, so on. Okay. So what is the total length of time slot? It is going to be 625 microseconds, among which some of the microseconds are given for hop. So it is 366 milliseconds the data can be transmitted. The rest of the time will be dedicated for the hop duration. The next one is about multiple secondary communication. Here you will have a master and you will have multiple slaves. So that's why it is called as multiple secondary communication. It is also called as multiple slave communication. Master uses even numbered slots. As we have seen, it will be using 0, 2, 4, 6, 8 likewise. And slave sends in the next odd number slot if the packet in the previous slot was addressed to it. So what does it mean? If the master is sending a frame in the even numbered slot, okay. So for example, if it's sending it in the F2, so the next frame, the next slot will be F3, right? That will be used by the secondary device or secondary station 2. Okay. So if it is addressed as F0, then it will be taken by the secondary station 1. Okay. So likewise, they will have some understanding so that the communication can be made. Next one is about the physical links. Two types of links can be created between a primary and a secondary. One is called as SCO links and the second one is called as the ACL links. SCO stands for the synchronous connection oriented. So what is SCO? Here latency is given more importance. Okay, that means the should be less delay. Okay, here it is not bothered about the error free transmission. It is only concerned about the delay. Okay, and here the transmissions are done with the help of slots, and there will be some algorithms running behind. And here there will be no retransmission. Once the frames are lost, it will not be retransmitted. One example for this SCO is real-time audio transmission, where the latency will be given the importance. The next one is asynchronous connectionless link. It is just the opposite of synchronous connection oriented. Here integrity is given more importance than the latency. Here the data should be error free or the frame should be error free. It does like multiple slave communication, and here retransmission will be done, whereas in SCO there will be no retransmission. The next layer in the Bluetooth is L2 CAP. Okay, it stands for Logical Link Control and Adaptation Protocol. It is equivalent to LLC, Link Layer Control Sublayer in LANs. It is used for data exchange on ACL link. SCO channels do not use L2 CAP. Frame format has 16-bit length. Then it will have channel ID, data and control. It can do multiplexing, segmentation, reassembly and quality of service. Here, if the quality of service is not provided, then the Bluetooth will be providing the best effort delivery. And it also can do the group management. It can do like multicast group using some kind of logical addresses. So this is the packet format of L2CAP. The packet format consists of the length, channel ID and data control. Here the length will be 2 bytes, channel ID will be 2 bytes and the rest of the bytes will be taken by the data and control. This is a frame format. So the frame format is going to be have access code, header and data. Access code is 72 bits, header is 54 bits and data is 0 to 2744 bits. Here the header is further divided into some fields. So totally the size of the header is 54 bits, which is actually 3 times 18 bits. Okay, so it will be permissible for 3 slots. So 3 into 18 is equal to 54. So what the header will comprise? It will have the address of the first slot, the type, the F, A and S fields and then the checksum. So we'll discuss about the frame format in detail. Access code, it is 72-bit field that contains synchronization bits. It identifies the master. Header, this is 54-bit field. It contains 18-bit pattern that is repeated for 3 times. The header field contains following subfields. Address, this 3-bit field can define up to 7 slaves. If the address is 0, it is used for broadcast communication from primary to all secondaries. The next field is type, which defines the type of data coming from upper layers. The next field is F. This flow bit is used for flow control. When set to 1, it means the device is unable to receive more frames. A. This field is used for acknowledgement. S. This bit contains a sequence number of the frame to detect retransmission. As stop and wait protocol is used, 1 bit is sufficient. Checksum. This 8-bit field contains checksum to detect errors in header. The last field is the data field. This can be from 0 to 2744 bits long. It controls data. Okay, it contains data or control information coming from upper layers. Next one is about the Bluetooth modes. There are 4 Bluetooth modes. One is the active, second one is sniff, third one is hold and fourth one is spark mode. Active mode, this is the regular connected mode where the device is actively transmitting or receiving data. The next one is sniff mode. This is a power saving mode where the device is less active. It will sleep and only listen for transmission at a set interval. Hold mode. Hold mode is a temporary power saving mode where a device sleeps for a defined period and then returns back to active mode when that interval has passed. The master can command a slave device to hold. So what is the difference between sniff mode and hold mode? In case of sniff mode, it is actually less active, but it is sleeping but not sleeping. That is a scenario of sniff mode. But hold mode, it completely sleeps for a defined time. Then last one is the park mode. Park is the deepest of sleep modes. A master can command a slave to park and that slave will become inactive until the master tells it to wake back up. Hope you have understood this concept. Thank you for watching. Bye-bye.